Hi, this is Terry Powell, and today I'm going to travel back in time nearly 40 years to the end of 1986 when I started my 39-year career with the federal government with the Department of the Army at Fort Stewart, Georgia, as the Director of Public Works, the DPW. Later, I transferred to the U.S. Army Corps of Engineers, Savannah District. Anyway, I spent approximately 28 years with the Department of the Army at the DPW and the USACE. And I also had a year-long deployment to Afghanistan with the Transatlantic Division. So anyway, that's what today's video is going to be about. I spent the last 11 years of my career with U.S. Department of Transportation, PHMSA, in Atlanta, Georgia. But I've already done separate videos on that part of my career. So today's going to focus on everything I did with the U.S. Army Corps of Engineers and the DPW at Fort Stewart, Georgia. Hope you enjoyed the video. Went to numerous training courses with the Corps of Engineers. They called them prospect courses, proponent-sponsored engineering training, something like that. It's the acronym PROSPECT. And also HVAC design courses at the Air Force Institute of Technology, Wright-Patterson, Ohio, and some PC course workshops and other training. And anyway, a lot of good training over the years. I began my career as a federal engineer on a co-op agreement between the Georgia Institute of Technology, Georgia Tech, and the Director of Public Works at Fort Stewart, Georgia. Here's me getting an award from a co-worker at the DPW at Fort Stewart. And I designed projects at the Fort Stewart Central Energy Plant and other facilities, such as this one. Here I am with my DPW co-workers at a wedding reception in 1994. Then in 1997, I'm here at the USACE Prospect Training Facility at the University of Alabama at Huntsville with a friend named Heather, the Tom Beeble Center. That's where we took all our training with the Corps of Engineers. I primarily design mechanical systems and buildings at Fort Stewart and other Army bases and Air Force facilities in Georgia and the surrounding states, like Fort Stewart, Fort Benning, Fort Bragg, Fort Gordon, Robins Air Force Base, etc. I did primarily heat and ventilation and air conditioning, HVAC systems, plumbing systems, fire protection systems like sprinkler systems, compressed air, natural gas service, and also boilers and chillers and high temperature and chilled water systems from the Central Energy Plant. Here's an example of a pre-engineered metal building that I did the mechanical systems in a new project. We also did a lot of repairs and renovation projects. I'm going to show a portfolio of my design calculations and mostly a lot of blueprints of the mechanical systems. We also did engineering technical specifications and cost estimates for these facilities. I started off doing heating and cooling loads with a simplified energy analysis method, ASEAM, microcomputer software. And this is an example of that. Later we switched to a more sophisticated Train Trace 500 heating and cooling load calculation software. Did the hydraulic calculations for fire sprinkler systems using a program called HOS. This is an example report from that program. It's from one of those Trace Load 700 reports that I did on the heating and cooling loads. And this is the system checksums, a detailed report summarizing. This thing went on for numerous pages. This is kind of the overall summary of a cooling load calculation and the cooling coil selection. Several more examples of the heating and cooling load calculation reports. Including the economic calculations. And here's another example of the hydraulic calculations for the fire sprinkler fire protection systems. Here are several drawing excerpts of HVAC plans, plumbing plans, and fire sprinkler plans from various facilities. This is the Fish and Wildlife building Here was a POL facility with tanks and piping. Central energy plant. The ENRD facility HVAC plan, plumbing plans, and the fire sprinkler plan. Here's the construct a medevac facility HVAC plan. An excerpt from another HVAC drawing. The Janus training facility HVAC and plumbing plans. And a facility for the DPS, the fire sprinkler protection plan. Here's an addition to Miles Warehouse, the sprinkler plan. Here's the Central Energy Plant chiller replacement project. Here's the hot and cold water plan and the sanitary sewer plan for an administration / classroom building for Wynn Army Community Hospital. Here's the HVAC plan and a detail for the heat pump, piping, and wiring system for that same administration classroom building. Here are the mechanical plans for constructing a maintenance facility. And here's a quick start program building out at Evans Field. And a kind of an enlarged HVAC plan excerpt showing 3 heat pumps and the hot and cold water plans. Here's how the R values of the roof was calculated for the heating and cooling load calculations. And here's the R values for the walls, including the coefficient of thermal conduction through the walls for the heating and cooling load calculations. I also did design studies and calculations to restore and improve the chilled water system for the Central Energy Plant built in 1412 at Fort Stewart. Here's an example of life cycle cost analysis, LCCA. Here's the header piping in the Central Energy Plant to the chilled water. Here's actual chiller performance and payback calculations and sample calculations on the capacity of the chillers. Our report identified numerous problems and came up with recommendations for the CEP study and a justification to invest in the project. And you can see some of the appendices had the calculated capacities for the chilled water pumps and the chillers. And for the different zones throughout the installation, all the gallons per minute flow rate calculations and the percentage pumping capacity. Diagrams of the chillers in the plant. And here's an aerial photo showing the Central Energy Plant building that had boilers and chillers, and then a large wood burning boiler on the outside. This was right after a tornado passed through in the mid-90s and knocked the stack down, which fell through the roof of the metal building, support building right there at the Central Energy Plant. Here's a news photo from 1995 that showed damage to the motor pools on base after that tornado came through. One building not shown here was destroyed, and there was one fatality. It was a major tornado, and the DPW worked with the U.S. Army Corps of Engineers Savannah District to do a lot of repair projects after the tornado. This drawing here I did of the wood burning boiler at the Central Energy Plant with the stack, showing the elevation view with the scrubber and the stack and the wood chip burning boiler, and all the structural steel framing and ladders to access all the parts. The Central Energy Plant provided high temperature water throughout the base to all the facilities and buildings that had heat exchangers. Here's some example calculations for a heat exchanger. The shell values and the tube side, and how you calculated the LMTD, log mean temperature difference, and came up with the U value. There were a lot of studies done on the high temperature and chilled water distribution systems at Fort Stewart and Hunter Army Airfield in Georgia. This is one such report showing the the boilers and the chillers at the Central Energy Plant. Here's a project I did to replace the Venturi scrubber controls and recorders for the wood burning boiler. And then this is the flow schematic for the Venturi scrubber controls and other features for the wood burning boiler. This drawing here shows the chillers and boilers inside building 1412. I replaced chillers 1 and 2, which were the 2 regular centrifugal chillers, 1,500 tons each, and there were 2 absorption chillers number 3 and 4, and then there were 3 gas-fired boilers inside the building that I had retubed in various projects. One project I did at the Central Energy Plant for the wood chip hopper was to put in a knuckle boom loader, the mechanical systems and structure to support that. This is kind of a crude drawing of what the concept was to put that knuckle boom loader in with hydraulic cylinder. Behind the Central Energy Plant, there was an above ground fuel storage tank. They had to do some ultrasonic testing of the plate steel. Anyway, here's some pictures and data on those tanks. Kind of a drawing that we did, some calculations I did for that project. Here's the POL tanks and piping. It's petroleum, oil, and lubricant at Wright Army Airfield. We'd had projects at Wright and at Evans Field with the POL facilities and piping. This is a schematic of the tanks and the piping with the filter separators. Here was a project to clean the storage tanks and install pressure gauges and air eliminators at Evans and Wright Army Airfield. Here's some calculations, head calculations for the diesel fuel systems on the suction and discharge side of the piping. And here are photos of the various pumps and piping headers and arrangements on those POL facilities. Here's some pictures of the storage tanks, the filter separators, the various valves and piping. And align the pipe supports and replace some of the piping. And a crude sketch with calculations on that piping when we put some GPM flow meters in. These are calculations on a 39-inch diameter exhaust stack. With the stack velocity and available draft. Determine if the draft was sufficient. And here's an analysis of the HVAC calculations on a psychrometric chart with the enthalpy and wet bulb temperature scales taken into account. Make sure you've got the number of tons of AC needed. Here was a project to replace the sand filters at the filter house for a large swimming pool. Here was a project to install a paint booth in a maintenance facility. The plan view, and here's the elevation, front elevation view with the air changes and exhaust system on top. Here were some lift station piping calculations, determine if the flow rate was sufficient for the force main to discharge the sewage of these lift stations. Here was a project for gas service regulators, this regulator assembly details, and also a nodeless meter risers, where the plastic pipe came out of the ground to the meters that you put in a nodeless riser that didn't require cathodic protection to be put in. Here was another gas service line project out in family housing, where it was proposed to put new polyethylene gas service lines utilizing the existing service as a carrier pipe. An example of a large cold storage facility. The calculations of the medium temperature racks and the refrigerant piping, checking the delta P, the pressure differentials, make sure you had oil entrainment and the right velocities for the refrigerant through this piping, make the receivers and compressors. Here was a study / analysis of mold and mildew problems in the 600 block buildings that I did, along with a list of recommendations. And in 1997, I was nominated for the Federal Engineer of the Year Award, largely for my projects at the Fort Stewart Central Energy Plant, and also the exhaust systems and all the tactical equipment shops around the base. And then in the next year, in 1998, I got my professional engineer license, passed the PE exam. And when I went to work for the U.S. Army Corps of Engineers, Savannah District, we did what's known as value engineering, VE studies, to make suggestions to improve projects designed by the architect engineer firms. And here's one example of a VE proposal to relocate condensing units closer to the split system air conditioning units, to save on length of refrigeration piping. Anyway, anything that improved the project or mainly involved cost savings were legitimate VE proposals that could be submitted for consideration. Here is an example of a VE study report for a battle lab relocation project at Fort Gordon, Georgia. This is what the cover sheet of these reports look like. Like I say, we proposed various VE proposals for cost savings and project improvements. You probably noticed most of the blueprints I showed in my portfolio earlier in the video were done with ammonia blueprints on the blueprint machine with manual drafting. Later, we started taking some courses on MicroStation 2D graphics, or basically CAD, computer-aided design. Intergraph was the company that provided this training and provided the MicroStation systems. Most of the private sector uses AutoCAD and other CAD software for drafting and mechanical design. So anyway, we were switching to that, but then I moved to the Corps of Engineers, and at the Corps, when we hired the AE firms to do designs, they were using advanced stuff called BIM, Building Information Modeling, and 3D graphic design. So anyway, that's something I would have had to learn if I had stayed in as a design engineer. I transferred to the U.S. Army Corps of Engineers, USACE, Savannah District in 2000, and served through 2014 as a construction contract claims manager, and then an integrator, pulling together value engineering studies, cost engineering, AE source selection, and master planning, and then a detail as a COR/acting chief of the AE contract section. Here's a picture of me in the Castle magazine on the right, where I took team members to see the results of their work out at Hunter Army Airfield. One of my first positions as a mechanical engineer with the U.S. Army Corps of Engineers Savannah District was called a claims manager, where I reviewed mechanical systems claims under construction projects and made recommendations and briefed the cases to the contracting officers, the attorneys, the area engineers, and project managers at the Corps of Engineers. And I had a professional article published on one of those that went to a Armed Services Board of Contract Appeals, ASBCA hearing, involving manual volume dampers and HVAC systems. And this was the Azure Journal article I had published. I also testified as a witness for the government in another mechanical project that I had actually designed while at Fort Stewart, Georgia, on the cold storage facility. That one had an ASBCA hearing, and the government prevailed in that case. The claim that went before the Armed Services Board of Contract Appeals that I reviewed involved a project at Fort Bragg, That one we actually settled and did a modification for the claims that had merit and denied the rest of them. And we reached a settlement agreement instead of going for a full hearing on that in that case. The large claim that I ended up doing a $9 million modification on was involved the Fort Bragg Womack Hospital, conflicts with the ductwork and mechanical systems in the hospital building and the interstitial mechanical room spaces, and the resulting overhead and other costs. Anyway, we settled that one, and I did a contract modification for the issues that had merit. While in the claim section, in the construction division, I did a lot of writing in that position, and they sent me to the Army Management Staff College Sustaining Base Leadership and Management Program. And here's a paper I did on earned value management and NAS network system scheduling tools and state of the art for construction schedules. Here's another VE study. I was on the VE team. We came up with several ideas to improve the project. Eventually held several other positions at the Corps of Engineers in Savannah District. Here's one where they sent me to Fort Gordon to do a HVAC system evaluation study, come up with recommendations on how to improve the mechanical systems at Greeley Hall, Fort Gordon. Here's me attending the Army Management Staff College Sustaining Base Leadership and Management Program, 2002 through 2003 at Fort Belvoir, Virginia. That program, we got to go on a midterm to Fort Monmouth, New Jersey, and then to New York City, the United Nations. And here's us at the bottom graduating at Fort Belvoir, Virginia. And in October 2011 through October 2012, I deployed to Afghanistan, part of Operation Enduring Freedom with the U.S. Army Corps of Engineers, Transatlantic Division. Here's us in Winchester, Virginia, before we deployed. The military took us out to the range and let us shoot some of their weapons in Afghanistan. And at the bottom here is a project with the project team on a perimeter fence and guard towers project that I worked on as a project engineer. Here's me with some of my co-workers at Shindan Air Base and then later in Herat at Camp Stone, Afghanistan. Here are some of the projects I was involved with during my year-long deployment to Afghanistan. This is the perimeter fence and guard towers project. Here was a wastewater treatment facility, doing the concrete work for that. This is probably the same project. Here's where they did the trenches for the communications for the perimeter fence and guard towers. I believe this was part of a munitions storage facility. Here's the team on the perimeter fence and guard towers project. I'm the one in the kind of the maroon or red shirt. This was at the new Shindan resident office that we had built. And here's the resident office and the sleeping quarters where they had these Connex shipping containers that we made into like the barracks facility there at the new resident office. Here's them doing concrete and rebar work. And here's us redeploying back to the United States after our temporary deployment was over. And after 28 years with the USACE, or the Department of the Army, I transferred to the USDOT PHMSA in 2014, where I worked another 11 years, ended up with nearly 39 years of federal government service. I've done a separate video on my time at PHMSA with the Pipeline Safety Administration.